So now in this example, we're going to do one that does not have any freebies. Steps stay the same, we just don't have a freebie to start off with. We're still going to start off looking at which variable it is that we want to eliminate. So as I look at this guy, I start off with the x's, and I want to say, how hard would it be to eliminate the x's twice? So with the first and the third equation, I would need to multiply one of those guys by -1, and then I have to multiply one by -2 to get rid of the second one. That's not horrible. Let's see if there's any easier. We'll look at the y's. Well, the first two are set up for elimination already, so that's not quite a freebie, but it's pretty darn easy. So y's are kind of winning so far. And then same thing, you got a 2y in there, we're going to have to get one of our other guys up to a -2y. Not too shabby. If we look over at the z's, z's are very similar to the x's. For the first two, I'm going to have to make one of them the opposite. So I think I'm leaning towards the y's because of the fact that the first two are set up. It's not free, but it's very little work. So I'm going to make a note to myself that my goal is to eliminate y's. And I always make this note because with this two equation, two unknown system, I don't want to get lost and say I eliminated the y's for the first equation, but then I eliminated the x's for the second equation. I write this down so I can always remind myself, oh yeah, I'm trying to eliminate y's. So off to the side, I'm going to do my work. So one of my pieces of work is to use equations 1 and 2. So I'm going to copy down equation 1. I'm going to copy down equation 2. It's not always equation 1 and 2. We just have to do this in two different ways. I'm choosing 1 and 2 because of the fact that the y's look so easy. So if I add these together, I end up with 3x plus 2z equals 9. I'm just going to jot this over into my area for my two equation, two unknown system. And there's one of my two equations. Now, I've already used equations 1 and 2, which means I need to somehow use equation 3. Since I'm trying to get rid of the y's, I need to make sure I get rid of that 2y. So that's what I'm focusing on, is making sure that I can get rid of that 2y there. So in order to do that, maybe I multiply the second equation by 2. That'll bring him up to a -2y. Now I could have multiplied the first equation by -2. That'd work as well. There's no right or wrong way here. What is important is that we end up using all three equations. We can use the same equation twice. So in multiplying that second equation by 2, I get 4x minus 2y plus 2z equals 6. And I copy down the original third equation. And then I'm going to add these guys together. That gets me 5x, 5z equals 20. Now I could go ahead and write this over my two equation, two unknown system, but I'm noticing that everything in here is divisible by 5. So before I write that over, I'm probably going to try to make my numbers smaller. And I'm going to say, let's divide both sides of that equation by 5, and it becomes x plus z equals 4. Now my numbers are a lot smaller, easier to work with. Always a good idea. So coming back over here, we've got ourselves x plus z equals 4. This is where we pause, we take a breath. This is the new material. We're done with the new material. Now we're back to two equations, two unknowns. We focus on just this two equation, two unknown system, and we solve it. So I'm going to go ahead and now try to eliminate, I think the z's probably. I'm going to multiply the second equation by -2. So I'm going to copy down the first equation. And I'm going to get -2x, -2z equals -8. I'm going to add those together to get x equals 1. I'm going to finish solving the two equation, two unknown system by plugging this x equals 1 back into one of the equations from the two equation, two unknown system. That's going to give me 1 plus z equals 4. If I subtract the 1 to the other side, I get z equals 3. Now I need to solve for y. I have the x and the z, and I need the y. So I look back to the original system and I look for which equation looks like it would be easiest to solve for y. I notice that I have a y with a coefficient of 1 in the first equation, so I'm liking the first equation. So that means I'm going to plug z equals 3 and x equals 1 into that equation. So I'm going to replace the x with a 1, I'm going to replace the z with a 3, and I'm going to solve that equation. 1 plus 3 is 4. Subtract the 4 to the other side gets me 2. Now that I have all three, I can write an ordered triplet. The x value is 1, the y value is 2, and the z value is 3. So there's my answer, 1, 2, 3. So if we look big picture at this, we chose the variable to eliminate. Then, off to the side, we did some scrap work to eliminate that variable in two different ways. That resulted in two equations, two unknowns. We then solved the two equation, two unknown system. And then we took the answers from there, plugged them back into the original to get our third answer. And those are the basic steps that we can always follow in every system of three equations, three unknowns. Now, before I release you to work on your practice problem for this one, I do want to point out that after your practice problem, I'm going to go ahead and show you how this one would work with substitution, just to show you you don't want to do it. And in doing so, I want to point out that this whole process, this entire problem fits on one screen right here. Not too shabby. All right, we'll come back to talk about the substitution method.